When we're evaluating limits, there are a couple of different ways we have to approach it. But the first thing is we do try to simply substitute in for the x and see if we get a number. So for example, if we wanted to find the limit as x approaches 0 of the square root of x squared plus 4, the first thing we would do is plug in x and see what happens. So here, 0 squared plus 4 is 4. We take the square root, and this answer is simply 2. And that's it. We're good. However, what about something like this? Let's say that we want to find the limit as x approaches -3 of x squared plus x minus 6 over x plus 3. Well, in this case, if you plug in -3, up in the numerator, we have +9 minus 3 minus 6. Down in the denominator, we have -3 plus 3, so that's 0. And in the numerator, we get 0 as well. So this is 0 over 0, which is indeterminate. Means we don't know what it is. It could be a weird number. It could be a normal kind of number. We don't know, so we have to do something else. And so from here, we look at the two options that we typically do. The first option is to try to factor. And in this particular problem, if we factor, we get x plus 3, x minus 2. The x plus 3's will cancel, and now if you plug this in, we get -3 minus 2, and we get -5. And that will now be the value of this limit. So if you get 0 over 0, then you may need to factor and get the answer. And that'll be it on that one. But then there's this other case where we have a square root, and so it's not quite like factoring. So let me take a look at one of those. If we do the limit as x approaches 0 of the square root of x plus 1 minus 1 over x. First thing, we try to plug in 0. Square root of 0 plus 1 minus 1 over 0. We get 1 minus 1 over 0, which is 0 over 0. Again, that is that indeterminate, so there probably is a value, but we just don't know it yet. To do this problem, we want to get rid of that square root. We can't factor here because we don't have a square root way to factor. So what we can do instead is multiply by the conjugate. And so here's our original function that we're trying to evaluate the limit. And then we multiply by the conjugate, which is multiplying by 1. Notice here I do the same thing on the top and the bottom. And instead of this negative sign that's in between those two terms, we have a positive. So you're going to change the operation. So one of them needs to be negative, one of them needs to be positive. And the reason we do that is because when you FOIL just the top, we're not going to FOIL the bottom, the square root terms go away. Because the square root of x squared plus 1 times the square root of x squared plus 1 is simply x plus 1. And then you have a positive x plus 1 and a negative square root of x plus 1 when you do the outer and the inner. And then the last, -1 times +1, we get -1. And in the bottom, we still have x. Don't do anything to the denominator because part of the trick here is that it does simplify. So don't do anything to the bottom. You'll see what happens. Here, the ones cancel, the square roots cancel, and we have an x in the numerator, an x in the denominator, and a square root of x plus 1 in the denominator. And so these x's cancel, and now we can substitute and get a value. So if we plug in 0 at this point, there's nothing left in the numerator, so it's just a 1. And then we have 0 plus 1, and that gives us 2 in the denominator. So our final answer is 1/2. So sometimes we just plug in the x value, and we get a number. Sometimes we plug in the x value, and we get 0 over 0. And then our two choices that we usually do from there are factoring or this conjugate thing.